So, vectors are GCSE questions, just a few from the past few years. So let's have a look where we get to with this, okay? Some of us are struggling, that's okay. So the diagram shows a parallelogram. The point B has coordinate 5, 8. Okay, so I know that this is 5, 8, okay? It says AB is 2, 7, so it means from A to B, okay? To get from A to B, I've gone across 2 and up 7. Now, it might not ask us to write the coordinates of A, but however, if we've gone across 2 and up 7, if I'm at 5, 8, I go down 7 and back 2, yeah? Remember this 7 is the vertical, so I'm going to take away 7 from 8, which is 1, and then 5 take away 2, 3. By the way, guys, if you guys are happy, you only have to listen if you don't know how to do this one. Then it says AC is 10, 11. So from A, we go across 10, so we add 10 to the x coordinate, and then we went up 11. So 1 plus 11 is 12. Coordinates of C, 13, 12. Okay, so this is 3 marks that was worth. Okay, and this is the basics of vectors. If we understand this is all movement, you know that 10, 11, this is what 10, 11 means. Okay, this is the basics of movement. If you can crack this, if you understand this, everything else will come simply. It says the point E has coordinates 63, 2, 1, 1. Okay, so E is across 63, up 2, 1, 1. So if I was to plot this on the graph, probably thinking E's about here, isn't it? Yeah? Okay, so there's my E. However, obviously, when you're in the exam, you don't have that. So, that's okay. So E is 63, 2, 1, 1. Let's, I'm just going to leave that for a second. I don't know what to do with this piece of information yet. So, use a vector method to prove that ABE is a straight line. Okay. How do I prove that a vector is a straight line? Yeah, we prove that AB is parallel to BE because one of them will be a multiple and they share a common point, B. Okay? So, how do I go AB? They've told us in the question, to get from A to B, I've gone 2, 7. Okay? B to E. Now, B is 5, 8, and E is 63 and 211. How have I gone from 5 to 63? What if I have to add on? 58? Is that right? Going for 58. 8 plus what is 211? 203. Okay. Can I write 58 and 203 as a factor of 2 and 7? If I divide 58 by 2, what do I get? 29. What's 7 times 29? I hope it's 203. Okay, so what we actually see, okay, I'm just going to bring this here closer, is that 58 can be written as 2 times 29, and 203, believe it or not, can be written as 7 times 29. So we can see they both share a common factor, 2 and 7. So I can say, so AB is 2, 7, yeah? And BE is 29 lots of 2, 7. They're parallel lines because one is a scalar of the other, yeah? One is a multiple of the other. They both contain 2 7s.
Would this always work?
This always works because this is the proof. We have to prove they're parallel. Have we proved they're parallel? All we've done here is, you know the line AB is 2, 7. Okay, it means I've got across 2 and up 7, okay? So my line is actually this long. BE, I've got across 2 and up 7, across 2, up 7, 29 times. My line is that 29 times. Is my gradient the same? Yes. So they're parallel. However, because they share a common point, B, it also means they are a straight line. So I know we've been proving this in terms of the vector A and B, but we should be able to prove this using when we get the numerical values as well, okay? And you have to write a sentence. Remember to write a sentence. I've just explained it. So there we go. Okay, just to clarify, the sentence is this. AB is parallel to BE. They share a common point B, therefore ABE is a straight line. Another way we could have done this, because it is only worth 2 marks, guys. However, we're prepping for the A-level, aren't we? But just like if they're parallel, they must have the same gradient. If I go across 2 and up 7, what is my gradient? It's 7 divided by 2. And then for this one, I've gone across 58 and up 203. I think you'll find that 203 divided by 58 is equivalent to 7 over 2. They have the same gradient. If they have the same gradient, they are parallel. And if they share a point, straight line. Perfect. Okay, here's a question. This one looks really easy. I hope it is. So, let's read it. N is the midpoint of BC. So what's the first thing I'm going to do? A half and a half. Okay. C is the midpoint of AD. A half and a half. M is the midpoint of AB, such that AM is 3 and this is 1. So what's the total? 4. Perfect. Okay. AB is P. Okay. Oh my God. I need a different, I'm going to get black involved. Okay, so AB in this direction is P. AC is Q. And because we know that that is the same as CD, this is also Q, isn't it? And I'm going to get rid of these halves because these ones are going to confuse me now. But everything else is fine. Wants us to find BD. So where's B? Here's B. Right, guys, BD is from here to here, yes or no? Yes. However, have I been given any information there? Okay, no, so I look for another way to get to B to D that has information. Can I go this way? No, because I still don't have any information. That's fine, so I go this way. What is this? Minus P. So I'm going to write that down, minus P. And then, if I carry on, I get Q plus Q, which is minus P plus 2Q. Some people might write that as 2Q minus P. Is that okay? Yes. Okay, MN. Where is M? Here, and I need to get to N. So, that's fine. M to B is a quarter P. So MM I can do by going MB plus BN. MB is a quarter P. We already know that. Now we want to go BN. Now BN is a half BC, isn't it? Plus a half of BC.
What is BC?
Well, BC we don't know this way. However, can we get there another way?
Yeah, minus P plus Q.
Minus P plus Q. So this becomes a half minus P plus Q. Now I'm going to do some quick maths. I'm going to expand this in my head. A quarter P minus a half P is... Okay, so minus a quarter P plus a half Q. Okay, state given reasons, 2 different geometric facts about MN and BD. Guys, remember, always check what you did before. MN, we just worked out. BD, we just worked out. So 2 facts about these two. Okay. Do we know anything? Is one a multiple of the other?
Oh, it's times 4.
Yes, it's times 4. So MN, 4 times MN equals BD. Yeah?
Say they're parallel.
Yes, and because one is a multiple of the other, we can also say
Straight line.
that BD is parallel is parallel to MN. It's not a straight line because they don't share a common point.
They do, they share B.
No. BD, MN.
Yeah, between M and they share
No. Does BD and MN share a common point? Do they share a common point, these letters?
Yeah. Because the path...
Forget the picture. BD, MN.
But it's the path we're
Is there the same letter twice?
No.
No.
But the path
So they do not
doesn't
share a common point.
The path doesn't matter.
No, there is no path because MN, we go this way. We would create our own path directly. We can create paths. However, we know if I created a direct path from M to N, okay, I know it'd be minus 1 over 4p plus a half q. I know that's how long it would take. We've just used this for our own paths, and then BD is here. Okay, so here we have a trapezium. What do we know about trapeziums? First of all, guys, what do we know about trapeziums? We know that these two sides are parallel. It's always in a trapezium. That's the rule, isn't it? As in, like, not the rule. Sorry, the definition of a trapezium is you have one set of parallel sides.
What is the factor?
What is the factor? Well, 3b equals x lots of 5b. So I'm assuming it would be 3 over 5 would be the factor. However, we don't need to worry about that. Okay. So. OA is 2A. Is that written on here? Yes. OB is 5B. Yes. AC. Did anyone think of Obi-Wan Kenobi when I said OB? Okay. And AC is 3B. Is that written on there? Yeah. Okay. So the diagonals OC and AB of the trapezium intersect at the point P. Oh my God. Right. So they intersect here. It's not going to ask us. Oh. It now wants us to find OP. Okay. So, to find OP, we have to find different ways to get to P. If that makes any sense. Okay? Different ways. So, let's start. What is one way to get to P? We can go directly to P, right? O to P. That's one way to get to P. I mean, I know it seems simple, but it is one way, right? However, O to P. This is something, so we say lambda, something times O to C, is it not? Because this is a proportion of the line O to C, yeah? Okay, so guys, that's one way to get there. Is that right or right? Perfect. Okay, there's another way to get O to P, and we cannot use this line. Another way to get from O to P is using a different way entirely. OA plus AP. Is that a completely different way? Yes, and we're using different lines essentially, aren't we? So we have OP can also be achieved by doing OA plus, now, to get from A to P, I have to do a portion of the line AB. Do I not? Perfect. Plus mu of the line AB. Okay? Everyone happy with this? So I've now got two different ways to get to places. Now, this is the hardest part of this, is actually writing these two statements. I'm now going to work on these two statements down here, separate, so we can see. So, lambda OC. OC, how do I get from O to C? What is the direction? We know that this length will always be the same. This is 2A plus 3B. So this is lambda 2A plus 3B. Okay, if I was to expand this out now, I'm going to get 2 lambda A plus 3 lambda B. That's it. I cannot go any further with that, can I? A lambda is just like we use alpha when, you know, when we just use alpha. It's just the Greek alphabet. And then we use beta. Okay, it's just like, and we use theta. Yeah, it's just a Greek alphabet. I'm just using a different symbol. You can use M and N if you want. Okay. Right, so guys, what is OA? 2A plus mu lots of AB. What is A to B? Minus 2A plus 5B. Minus 2A plus 5B. Okay, so then this is 2A minus 2 mu of A plus 5 mu of B. Yes? Or no? Yeah, okay. So now guys, we have to use a bit of simultaneous equations now. Okay, so here, if I just factorise out my A, or my 2A, I get 1 minus mu. Yeah? And if I factorise 2A on this side, I just get lambda. Are we okay? Right, guys, this means that lambda equals 1 minus mu. Because remember, they're both OP. Is everyone happy with this? It's like equating coefficients. Remember when we did trig, and we do the R cos rule, and we have to look at what's equal? It's similar to this. Now, the next one, I get 5 mu B. Well, actually, what can I take out from that? I'm just going to, if I take out B, what am I left with? 5 mu. And if I take out B here, what am I left with? 3 lambda. So that means that 3 lambda here is equivalent to 5 mu. Okay? Simultaneous equations now. Simultaneous equations. So, first one we have is lambda equals 1 minus mu. And 3 lambda equals 5 mu. So, that means that I'm going to substitute lambda into here. Is everyone okay with this? If you want, you can use x's and y's. However, in the mark scheme, I don't know why, but they always use lambda and mu. So, we have 3 lots of 1 minus mu equals 5 mu. So we're going to get 3 minus 3 mu equals 5 mu. You guys know about mu, the Pokemon, don't you? Good. So 3 equals 8 mu. So what does mu equal? 3 over 8. Okay? Lambda equals 1 minus mu. So what's lambda?
At some point you just start hitting mu.
5 8. So now I found out what lambda and mu equals. You'll find something. They add to 1, right? So, do you remember earlier we said that OP was lambda OC? This means lambda is what? 5/8. So this means that we worked out that the proportion, the ratio here, is 5 to 3. It's 5 over 8, 3 over 8. And then do you remember earlier, because it's actually a trapezium, funnily enough, we worked out is mu of AB that this is also the same. But I forgot what did the question ask us for. Oh, I see. It wants OP. Okay, guys, really simple. Now we worked out all of this. It wants an easy thing for OP. We already know what OC is, don't we? All we need to do is here, where we originally put it, we just need to multiply by 5/8. So, 5/8 lots of 2a plus 3b is going to give us 10 over 8a plus 15 over 8b. This is a simple well, it's not quite simplified because 10 over 8 could be simplified to 5 over 4. However, shall we check we're right? Guys, we've done it. We figured it out. Well done. That was only a 5-mark question and it's taken us 10 minutes. Just to clarify, once we got to this bit, we then had 2 equations which were simultaneous equations because we equated the coefficients of A and B. Okay, 3-mark minute. This should take 3 minutes. Ready, set, go. Okay, so for this style of question, I suggest drawing the triangle. OAB is a triangle. Oh, low battery, 2%. O, A, B. So OAB is a triangle. OA is A. OB is B. The point C lies on OA. C lies on OA such that, the ratio is 1 to 2, so it'd be like this. 1 out of 3, 2 out of 3. And then the point D, so that's C. The point D lies on OB such that, so that would be here, D, so this is 1 out of 3, 2 out of 3. Use a vector method to prove that AB, DC is a trapezium. Okay, to prove it's a trapezium, we have to prove that trapezium, we have to prove that these two are parallel. So we have to prove that CD and AB, that one is a multiple of the other. Now, some people don't like to use mu, so I'm going to use alpha. We have to prove that one is a multiple of the other. Yep. So let's find CD. So to get from C to D, in that direction, I'm going to go negative this way. So negative a third A plus a third B. So negative a third A plus a third B. Then to get from A to B, well, this is easy. It's just A, negative A plus B. Negative A plus B. Well, we can clearly see that if that negative A plus B is multiplied by a third here, and negative A plus B is... Okay, one is multiple than another, so therefore we've proved they're parallel. Okay, of course you have to write a sentence, but remember we're doing this as a recap. We're not writing a sentence, we just have to understand how to get to this part. Okay, so question 6. Here are 2 vectors, 6 minus 9, and CB is 1 of 3. Now look at the directions. If I was to actually draw this, if you think this is A, this is saying I go across 6, down 9. I'm now at B, okay? And then CB, remember this direction, so if I'm at C, to get to B, so if I want to go backwards, if I want to start at B and go to C, I'm going to do the negative of this. This will make my life easier. So minus 1, which means left 1, down 3. So my C is here, okay? Gone down and here. So now if I'm thinking about A to C, I can now add AB plus BC. That will give me A to C. Now remember BC, I have to do the negative of CB. So I'm going to get 6 minus 1, which is 5, minus 9 minus 3 is negative 12. Okay, now that I've done that, that's saying from A to C, I've gone across 5, down 12. So if I want to find the magnitude, I want to find the length, do 5 squared plus 12 squared, which we all know is 13 squared because it's a Pythagorean triple. So that is how we found it's 169. Square root of 169 using Pythagoras. Okay, question 7. ABC is a triangle. The midpoint of BC is M. P is a point on AM. Okay. So if we know that's the midpoint, we know this is a half and a half. I always like to write everything down. AB is 4A. Yeah. AC is 2B. AP is 3 over 2A plus 3 over 4B. Okay. So this is 3 over 2A plus 3 over 4B. And this is only A to P, isn't it? So I'm just going to, that's only that section. Okay, it says find the ratio of AP to PM. Okay. So. Okay, so how do we get from A to M? Now, I can go a few different ways. I can do AB plus BM. So AB plus BM, which we know is a half of BC, okay, in this direction. So AB, so this is it's this. So AB is 4A plus a half of B to C. So B to C, I don't know this way, so if I go here, minus 4A plus 2B, minus 4A plus 2B. So I'm going to get 4A minus 2A plus B, so I get 2A plus B. Okay? Now, so this is A to M. So AM is this. Now, if I was to split this, I know that AP plus PM needs to equal 2A plus B. Now, if AP is 3 over 2A plus 3/4 B, what do we need to add to get to 2A to B? Now, we can clearly see that this is 3/4 and here we have a whole one. So we have to add on a quarter. So that means my ratio is that AP is 3/4 and PM is a quarter. So my ratio is 3 to 1 because that's a total of 4 parts. Now, this is literally, I've just done this by looking and just being a bit sensible, okay? That is the best way with vectors sometimes. You just have to be sensible, common sense. Okay, question 8. So, OA is 2A. Okay. Oh. 2A, OB is 2B. M is the midpoint of AB. So that's going to be a half and a half. N is the point on OB, such that we have 2, 1 out of 3. Okay, so let's also as well fill out any information that we definitely need. For example, A to B. My lightsaber's not working. Oh, there it is. Right, A to B. What is A to B? Minus 2A plus 2B, right? So this is minus 2A plus 2B. That is A to B. Okay, we know that M is the midpoint, so we know that A to M is half of this. Okay, so this is fine. So let's get that written on there. Then what? Right, we're now going to go O to P. Okay? O to P. Straight across that way is no, we want O to P is X lots of O to M. Because we multiplied, so remember. Okay, it's only part of it. So we should be happy at this stage. So we definitely know to get from O to P is X lots of O to M. How do we get from O to M? What are we going to do? Yep. So O to A is 2A plus A to M, which is plus a half lots of minus 2A plus 2B. Okay, so expand and simplify. I'm going to get X lots of A plus B. However, I always, whenever I'm doing these questions, I want to always have my A and B and everything else is factorized, because then we're going to be able to equate coefficients, okay? Right, so we've now done this one way. Now we have to find a different way to get to O to P. So now a different way, we could do O to N and then N to P. So we're going to have O to M. So another way to do O to P is to do O to N plus Y lots of N to A, if we're going in that direction. So what is O to N? O to N is 2/3 of 2B plus Y lots of N to A. Now, we don't know N to A, but what we do know is I can go from N to A. So we're going to have minus 2/3 of 2B plus 2A. Okay, I now need to expand and simplify. Now, if for ever reason, no, that doesn't make sense. For any reason, if you end up and these two aren't right, it's probably you've done the same way twice. It might look different, but we've actually gone two specific different ways. So what is this going to give me? 4 over 3b minus 4 over 3by plus 2ya. However, what I'm going to do now is make sure I factorize out my a's and b's. So I'm going to get b lots of 4 over 3 minus 4 over 3y plus a lots of 2y. Then, using simultaneous equations, we have, we're going to equate coefficients. So the a is here, so a is 2y. X equals 2y. Okay, so we could say that y equals x over 2, either or. And then we have 4 over 3 minus 4 over 3y equals x. So 4 over 3 minus 4 over 3 y equals x. So however you want to do it now, we can substitute in any which way. So if I substitute in x equals 2y into here, I'm then going to have 4 over 3 minus 4 over 3y equals 2y. So then if I do 2 plus 4 over 3, I'm going to get 10 over 3. So 4 over 3 equals 10 over 3y. So then that means that y equals 2 over 5. And then x equals 4 over 5, because we know x equals 2y. Now that we have this, let's have a look at what is our x. What did we say that x was earlier? We said OP is x lots of OM. Okay, so this x lots of OM, this is x. So we know x is 4 over 5. So this is 4 over 5 parts. So this must be a fifth. So the ratio is 4 to 1. And then remember our y, you might be thinking, well, why does y and x not add up to a whole one? It's because remember our y is this part here. So actually the line APN is split into 2/5 and 3/5, okay? But the line OPM is split to 4/5 and 1/5. And what did it want? OP to PM. So that's where these other values come from. So remember, you're always referring to what you've worked out. Well done.